lesson focuses on restricted domain and piecewise functions. The piecewise functions are created based off of a restricted domain. So, before we begin, number one, you're given this graph, which is a piecewise function. This is what it looks like. You had to find domain, range, and continuity. Okay, intervals of continuity. Anyone have any guesses in terms of domain? Louise? Okay. Anything else? Okay. All right. Someone else? Harris? We're just gathering some information on who did what. Danielle, what do you have? Okay. Oops. Someone have something else that's not up there that you want to share? Did anyone have an option negative infinity to 5? Yes, no, maybe so. Some of you had. Okay. So those are some options that came up. Were there any others for domain? Okay. Okay. All right, the correct answer for domain, if you take your pencil across, okay, and you're looking at the x values. So we have negative infinity to 2 with parentheses, because that is included. Remember, closed circle overrides an open. So if we keep going, but there's a gap right here between 2 and 3. So we have to do union 3, 5 with a bracket. Okay. One of the options that was mentioned, this one here, if it had parentheses only, that would be intervals of continuity. Okay. So your intervals of continuity mean this graph is not continuous because you lift your pencil. Okay. Twice. You lift it from here to here. So you have to break it up. Negative infinity, negative 2, union, negative 2 to 2, union, 3 to 5. Okay, and it's always parentheses. So, negative infinity to negative 2, I have to leave the paper, and then go from negative 2 to 2, leave the paper again, then 3 to 5. Okay, that's the difference between interval continuity and domain. Yes? Where? It's an open circle. Okay, open circle. All right. How about my range? What's my range? Paris? Okay. So negative infinity to 3 with parentheses. Anybody have something else? Is every y value being used? Addison? Okay, so negative infinity to 2. okay, with parentheses. And union, the 3 would actually be in brackets because there's closed circles here as well. And remember, closed circle overrides open, but nice job, okay? Those types of problems get a little confusing, but closed circle overrides an open. So all this y value here is being used, yeah.
So it, would it be about, like, if the one at the top was closed circle, but then the other three parentheses?
If this whole thing was closed, open, I mean. If it was closed circle, it would still be bracket. Yeah, it would still be bracket. Because the 3 is also being used here. So it's not necessarily a point per se that you could see individually, but 0, 3 is part of this location. Okay, so that's where it gets, and these are all great questions. No matter what, closed circle or the line that's there overrides the open. All right, so that's why we have brackets around just the 3. All right, any questions? Yep. It's right here. Go from bottom to top. This is used here, and then 2's right here.
Oh,
Okay? Because there's a gap between 2 and 3. 2.5 is not being used, for example. Okay? All right. Now, number 2, you had to graph these equations. So 2a, what type of graph is that? Linear, good. Where do I start? Graphing this, please. 2, and then what? Down 1 over 3. Down 1 over 3. You could also go in the opposite direction. What's the opposite of down? What's the opposite of right? That's how you come up with your other points. Okay? Our linear equation. Then B is what? Liam? Quadratic. And with quadratics, what's the first thing we look for?
For just the k, which represents the -4 and the -1.
Would it be -4?
No, -4 is positive 4.
Good. 4, -1. And again, the a value is 1, so if you remember, up 1 to the right, up 1 to the left, then back to the vertex, up 4 over 2. Okay, good. All right. How many of you got all of 2 correct? All of 2. Good. Okay. Now 3a is writing equations. What is our equation for 3a? Nolan? Just -x? Good. Okay. Y equals -x plus 4. Here's our y-intercept. You could figure out the slope or pick another point to find the slope. Yes? Yeah, Liam. Let's see if there's someone else first, okay? Thank you. How about B? Nobody? Yes, thank you. Yep. Awesome. Good job. Liam, was that what you had too? Awesome. Good job. Okay. It is a quadratic. Excellent. Negative because it's reflected. X plus 3 because you move to the left. And then plus 2 because you move up. Okay. Excellent. How many of you got all of 3 correct? Okay. Good. So today we are going to look at our lovely library of functions on a restricted domain. So when you hear a restricted domain, what does that sound like to you? Yeah, Dino. a set of values from like start to finish, pretty much, okay? A restricted domain is a portion of a graph's domain in which we'll be given an either interval notation or inequality. Inequality notation. Interval or inequality. Okay? I want you guys to recall, if there is a bracket, then there should be what kind of circle at this location? Opened or closed? Check. Closed. And that also goes with a bracket if you had less than or equal to or greater than or equal to as well. So bracket, less than or equal to or greater than or equal to, will have a closed circle. Okay? Then if there's parentheses, what type of circle should we have? Danielle? Open, which is another term for that, is a hole in the graph where there's like a break. So that could be also less than or greater than. If we restrict the domain from 3 to 9, that means the graph should only be on when x equals 3, and the point would be an open circle because it's parentheses, and when x equals 9 because it's a closed circle. Okay? So we're going to look at what these restricted domains look like. All right, starting with number 1. Okay? We have f of x, our function here, over the domain 0, 5. So, Cece, what type of function is this? For number 1. It's the v. Good. Let's see. Caitlin, do you know what name for this one? What's the name of the function? It's the v shape, which is? Awesome. Good. Good job, you guys. Absolute value. Okay? So with absolute value functions, they have a vertex of what, Blake? You have it in front of you too if it's hard to see up here. So our vertex is 3, negative 5. Okay. Then they're telling us it's on domain from 0 to 5. So we have to look at the left side of the domain, which is x equals 0. We have to find the corresponding y value that fits that. So all we're going to do is substitute it in. Okay. We're going to substitute 0 into the equation to find our y value. So 2. What is our corresponding y value for that one? Jackson. 1. Okay, so 0, 1 would be 1 point on this restricted domain. Would it be opened or closed? Taylor? Careful. Closed, because of the bracket here. Okay, so it would be closed. So now we also have to find the right side of the domain. So we're going to put x equals 5 into the equation. Okay, so what is our corresponding y value for x equals 5? Sabrine. Negative 1. Now, Lila, is that going to be opened or closed? Open, good. All right, so we have three values right now to plot. We have our vertex, 3, -5. Okay. Then we also have 0, 1, which is a closed circle. Then we have 5, -1, which is open. Okay. With absolute value, what can I use to find additional points or additional values? Yeah, Danielle. Oh, was that a hand? Oh, go ahead. Go ahead.
Well, you can use like linear functions go down, so you would go down to the left.
So we would use our, what is that called? Slope, right? So our A value is our slope. So we could go from the vertex up to the right, up to the left, up to, and connect. That's our absolute value function on a restricted domain. Okay? If you don't remember slope, you could plug in values from 0 to 5 to find your nice graph. Okay? Questions? All right, let's look at number 2. Okay. What type of function is this? Liam?
Quadratic function.
It's quadratic. Therefore, our vertex is what?
It's would have to be -1, negative.
Good. Our vertex is -1, -3. And our domain is from -3 to 3. So the left side would be -3. Right side would be 3. So what we have to do here is plug in those x values. So we start with x equals -3. 0.5 is also what?
0.5 is also
1/2. It's okay. So -3 plus 1 squared minus 3. Okay. What do we get for a corresponding y value for -3? Wes? -1. Good. And at -3, -1, is that going to be an open or closed circle? Go ahead, Wes. Open. Good. -1, -3. And then so far we know -3, -1. It's open. We also have to do the other side, which most of you have probably started already. X equals 3. I'm just going to write it out. What is our corresponding y value? Louise? 5. So at 3, 5, is that going to be opened or closed? Go ahead. Closed. Oops. Triggered in the wrong spot. Okay. And you do know if this is your vertex here, since it's by a half, you're going to see those points like that. And again, if you plug in any x value between -3 and 3, you could find a great graph. Okay. Any questions? Yep, Liam.
So what defines again what makes a point open or closed?
Okay. Great question. Parenthesis here. So when I plug in -3, this already has a parenthesis. So that means this one would be open. And then when x equals -3, and then when x equals 3, it would be closed because of the bracket. Okay? And that includes the y value as well. All right? All right. Let's try a few more. Okay, for number 3, what type of graph or equation is this? Brayden. Square root. Good. This is the square root. Okay, so we use HK as our starting point. Yes. So what would our starting point be, Emma? Think of HK. Our starting point. So 2, 1. Good. Okay. 2, 1 would be our starting point. Okay. So 2, 1 is our starting point. But it's also on the domain of 2, 6. So which value did we already figure out? Danielle? Good. So 2, 1, we already have it here, is our starting point. So therefore it's going to be open or closed. Luis? Closed. So in this case it's going to be closed because there's a bracket. Okay? So left side of the domain is 2, 1. And this is closed. Okay? Now we have to find the right side, which is 6. Square root of 6 minus 2. What is the square root of 6 minus 2? What? Square root of 4, which is 2. We have 6, 3 as our other point. Is that going to be open or closed? Esteban? Open. Good. So this is open because it's a parenthesis. This is closed because it's a bracket. Okay. And another x value you could plug in is 3 if you wanted to, and you would find this point. So looking at this new graph, what is my range for this new graph, for this piece of the graph? Nolan? Yep. Your range would be 1, 3. Okay. Number 4, there's a little bit of a difference. What do we notice? Please? It's a reflection, yes, but anything else regarding the domain? Grace? Good. The domain has infinity. So what's going to change about one of the endpoints? Jack? It's going to have an arrow. So we're not going to have bookends to plug in, right? Like we just did. We are going to have one side that's going to be an arrow. Okay? So we know this is the absolute value function. And what is our vertex? Brayden? Good. -2, 3. So the only x value right now we could plug in that we know of is 2. You can plug in more, obviously, after this. So -2, 3 is our vertex. And then if we plug in x equals 2, what do we get? everyone's paying attention, I should have 24 hands up. Okay, if I plug in x equals 2, Sawyer, what do we got? -1. Is that going to be open or closed, Assad? Closed. Okay, so we have 2. -1 will be closed. So how can I figure out other points? Yeah, Grace. Sure. Because can we ever find a corresponding y value for that? No, because it includes all these values from 2 to -infinity. So we could only really find the 2, -1, and this is heading to -infinity. So it's going to be impossible. Okay? Because of the bracket.
Oh, it's on the, okay.
It's on the other side. So it should be actually on the right side of the domain. This should be here. Okay? So 2, -1 is on the right side, okay, of that domain, and it's a closed circle. So how can I figure out other values? Yeah. -1. So I could use my slope, right? If I go down 1 to the right, I also have to go to the left. Okay. But what am I going to put on the left-hand side, though? Addison? An arrow. Good. Now, do you have to graph all those points like I did? No. But you want to make sure you have an even graph. Okay, which, in this case, use a slope. It's easy. What is my domain, or my range of this function? Caitlin? Good. -infinity to 3, bracket. Okay. Okay. So, what you guys just covered just now is graphing our family of functions over a restricted domain. Okay. It leads to page 5. Okay, so turn to page 5 in this little box here. This is why we're doing the intro of family of functions on the restricted domain. Because eventually, and you're only going to see one today, we're doing these piecewise functions. Which means, in this example, we have 3 separate graphs. Each of those graphs has a restricted domain that we have to abide by. All right? So, if you notice, this first graph here, A, is when x is less than 0. So that first graph, 2x minus 2, is only in this region. Then you have -1, which is a horizontal line, from 0 to 3. Then you have -4x plus 16 when x is greater than or equal to 3. So you have this restricted domain. Each graph does not pass those boundary lines. It does not cross. Because think of it this way. What happens to a dog if they go past an electric fence? All 5 other classes know, besides you guys. What? They get shocked, right? So these little dashed lines here act like your boundary line, like your electric fence, like your territory. This graph cannot cross. It has to stay in this region. That's why we're looking at the restricted domain so closely. Okay? So, we define piecewise functions by 2 or more different functions and looking at different parts of its domain. No matter how many graphs we do, a piecewise function always passes the vertical line test. Looking at this example, why? Why would it always pass the vertical line test? Do you know? No lines overlap, and then if you look at the points, what's the difference? Yeah. There's an open and a close. If there was 2 closed points, would that be a function? No. It would not. So that's why we create these piecewise functions as sub-functions to create a brand new function. Okay? So what you guys are going to do to start, you're going to graph A and B like we just did. Okay? Graph A and B. Okay, Liam. Yes, you may. What you see down here is what a piecewise function looks like. This is what it looks like. All right? Piecewise function has both equations given the restricted domain. Okay? So you would be giving this, instead of graphing them separately, you will do everything all together. Okay? To then create, hopefully this works. Where'd it go? Hold on. Nope. I'm going to show you. 1, 3. So you're eventually going to create it on one graph. So this is what the piecewise function would look like. So right now, you're going to take those two pieces and put them on the graph below. That will be your piecewise function. And all I did for mine was just copy and paste, but you guys actually have to draw them both in, okay? Which is very simple because you did everything above. Okay. This is what your piecewise function would look like. So next class, we will be going through just jumping right in and graphing these and doing the same thing, but both graphs are going to be on just one coordinate plane. Okay? So your homework, page 4 in the notes, so one back, page 4, numbers 5 through 8. Okay, page 4, numbers 5 through 8. Then page 9, where it says 1.6 practice, page 9, 1 through 4. Okay, so page 9,